Welcome to this channel. In this tutorial, we will simulate an operational amplifier using MOSFET and LTspice tools. Let us start the circuit design of the operational amplifier. Click on New Schematic. Next, click on the Components. Now we have to select the PMOS and the NMOS. Now place the PMOS transistors as shown in the schematic. Now click on Components and select NMOS with explicit substrate connection. Click OK. Place the NMOS in the schematic. So in order to rotate the NMOS, use Ctrl plus R. In order to mirror the NMOS, use Ctrl plus E. Again, go to Components, select NMOS, place the NMOS in the schematic and mirror this particular NMOS by using Ctrl plus E. Now click Escape. Now the first stage of the design consists of 6 MOS transistor with 2 PMOS and 4 NMOS transistor, which would be our differential amplifier stage. The next stage of our design would be defining the input and the output pins. So we must click on Label Net and define the VDD pin, which is an input pin. Next, we have to define VSS, which is an input pin. Now click on Wire, connect the source of PMOS 1 to the source of PMOS 2 and the VDD to the source of PMOS 1 and PMOS 2 and the gate of PMOS 1 to the gate of PMOS 2. Now the drain of PMOS transistor, that is PMOS 1, is connected to the drain of the NMOS 4 transistor and the drain of the PMOS 2 transistor is connected to the drain of NMOS 3 transistor. The source of NMOS 4 and NMOS 3 is connected and the source of NMOS, which is transistor number 3, is connected to the drain of transistor number 5 and the gate of the transistor number 5 and the transistor number 6, which is an NMOS, is connected and the source of transistor number 5 and transistor number 6 is connected to VSS, which is an input pin. Now again click on Label Net and we have to define our input V1 and then click on Label Net again and define the input as V2 and port type as input and place it on the schematic. Now connect the V1 to transistor 4 of NMOS and V2 to the transistor 3 NMOS. Now click on label net and define the port type as IDC, which is the input. Click on OK and place the IDC pin on the schematic. Click on wire and connect this to the drain of transistor number 6, which is NMOS, and the drain of transistor number 6 is connected to the gate of transistor number 6 and transistor number 5. Now make the substrate connection accordingly. Now once we are done with the all substrate connection, the first stage of the operational amplifier, which is the differential amplifier stage, is completed. Next we have to do the second stage, which is the common source stage. So for this we require a PMOS transistor, and go to components, select an NMOS transistor and place this on the schematic. Click escape. Now click on wire and connect the gate of transistor number 1 and transistor number 2 to the drain of transistor number 4, and the VDD is connected to the transistor number 7 of PMOS, and the drain of transistor number 7 of PMOS is connected to the drain of transistor number 8 of NMOS, and the source of NMOS is connected to VSS, which is the input pin. Now from the IDC pin we must connect this to the gate of transistor 8 of NMOS. So click on wire and make the connections accordingly. Now the output of the differential stage amplifier must be connected to the gain stage, that is the common source stage. So connect the output of differential amplifier to the gate of PMOS transistor. Click on components and then select the capacitor. Make the capacitor connection between the gate of PMOS to the drain of PMOS and the drain of NMOS transistor. Now you can see that the model name is PMOS, but as per our BSIM4 models, okay, the name of the NMOS transistor is N_1 micro, and for the PMOS it's P_1 micro. So we have to define the model name as P_1 micro, and for the NMOS transistor it has to be n_1 micro. So make those changes. If you don't make those changes, then when you do the simulation you will get error. So define the length as 1 micro, width as 15 micro. Click on OK. Similarly, right click, define the model name as P_1 micro, length 1 micro. Right click on transistor number 4, define the model name as N_1 micro, and the length must be 1 micro, width has to be 3 micro. Click OK. Right click on transistor number 3, model name as N_1 micro, length as 1 micro, and width as 3 micro. Click OK. Right click on transistor number 6, N_1 micro, length 1 micro, width 4.5 micro. Click OK. Similarly, for transistor number 5, N_1 micro, width, length as 1 micro, width as 4.5 micro. Click OK. Now for the transistor number 7, right click, define the model name as P_1 micro, length as around 1 micro, width as 50 micro. Click OK. Right click on transistor number 8, model name N_1 micro, length must be 1 micro and width must be 20 micro. Click on OK. Right click on the capacitor, define the capacitor value as 10 picofarad. Now click on label net, define the output, which is Vout. Select the port type as output, click OK, and place this pin on the schematic. Click on wire and make the following connection. Now the first part of our design is completed. We have defined the schematic of the operational amplifier. The next stage would be creating an symbol for the operational amplifier. So this particular symbol can be used for any kind of simulation. Now define the substrate connection of transistor number 7 and transistor number 8 accordingly. Now the complete operational amplifier schematic has been completed. The next stage will be defining a symbol. So click on edit and click on spice derivative. Now you know that we have included BSIM4 model, so we have to define this particular syntax, and this BSIM4 model has to be included in our schematic, or else we would end up in error. So it has to be dot include bsim4 underscore models dot text. Click OK and place this on the schematic. Go to file, click on save as, and save this particular operational amplifier circuit. Click on save. The schematic has to be saved in this particular folder where we have this BSIM4 model file, or else it would, when you perform the simulation, you would end up in getting the error. on draw, select rectangle and make a rectangle, click escape. Now go to edit and type add pin port. Define the label as V1, click on write and click on OK. Place this on the schematic. Again, go to edit, click on add pin port, define the label as IDC, click on write and place this on the schematic. Similarly, we have to do the add pin port for all our inputs and the output, which is VDD, VSS and Vout and V2. Now, once all the add pin port has been placed on the schematic, next click on draw and click on line. Connect the IDC pin to the rectangle, which is our op-amp symbol, and V1 to the rectangle. Similarly, we have to do the connections for V2, VDD, VSS and Vout. Now, to add a text, like defining this particular symbol as an operational amplifier, click on draw and click on text. Define the text such as op-amp and click on OK and place this on the schematic of the symbol. Now go to file, click on save as and ensure that you save this particular symbol in a folder called as my symbol for your convenience purpose. We will call this particular operational amplifier symbol in our next simulation purpose for transient analysis, for DC analysis or for the AC analysis. Click on new schematic. Now we will perform the simulation of the operational amplifier. So click on component and select the operational amplifier symbol which we had done. So select operational amp and place this particular symbol in the schematic. Click escape. Now we require the voltage source for this particular simulation. So click on voltage source and place this particular voltage source V1 in the schematic. Click escape. Now draw the wire from V1 to positive terminal of V1 to the VDD pin. Select the component and click on voltage. and place this particular V2 source near VSS pin. Click escape, click on wire, connect the positive terminal of V2 to VSS pin. Next, we require a current source. Click on the current source and place this on the schematic. Click escape and next click on wire, connect the positive terminal of V1 to the I1 and the current source to the IDC pin. Next, click on ground. Place the ground connection near V2, V1 and also near the input pin and the output pin, which we will do later. Now connect the negative terminal of V1 to the ground and the negative terminal of V2 to the ground. Now click on component and select the voltage source. Click OK and place this particular voltage source near pin or the input V of 1. Connect the positive terminal of V3 to V1 and click on ground and place this ground connection next to the V3 source. Connect the negative terminal of V3 to the ground and the input V2 to the ground. Right click on voltage source V1, define this voltage source as VDD, click on OK. Similarly, right click on V2 and define this voltage source as VSS. Now, right click on the current source, define the value as 30 microamperes and the value of VDD as 2.5 volts and the value of VSS as minus 2.5 volts. Right click on V3 and define or select advanced. Click on sine, set the DC offset as 0, amplitude as 5 millivolt, frequency as 1 kHz. Click OK. Now change the name of V3 as V1. Now click on edit, click on spice derivative and include psim4 underscore models.txt. Click on OK and place this on the schematic. Now ensure that this particular schematic is saved in the same folder where the bsim model file has been saved and also the op-amp schematic symbol has been saved. Now to perform the AC analysis of the operational amplifier, click on edit. Click on spice analysis and select AC analysis. Select the type of sweep as octave, number of points per octave as 25, start frequency 7, stop frequency 150. And now place this particular syntax or the command on the schematic. Now right click on the source V1 and we have to define the AC amplitude as 1 in order to perform the AC analysis. Click on Run. Click on Vout. You can see the AC analysis of the operational amplifier. Thank you for watching this tutorial. I request you to subscribe my channel below for more such videos.